Part A. Find the distance x in the diagram below. It's not to scale. Give your answer correct to 2 decimal places. So we're trying to find this x here, the side of the triangle. The first thing you want to do is have a look and see, is this a right angle triangle or not? It's not a right angle triangle, so therefore we cannot use Pythagoras' theorem or SOHCAHTOA. We're not looking for the area, so we're not going to use the area formula, so we're left with the sine rule or the cosine rule. So you should always try the sine rule first, and if that doesn't work, then try the cosine rule. So the sine rule is on page 16 of our formula book, and it is a over sine A equals b over sine B equals c over sine C. So we're going to label our triangle. So I'm going to let this be capital A, so that's lowercase a. I'm going to let that be capital B, so that's lowercase b. And I'll let that be capital C, so that's lowercase c. So I'm going to have a over sine A is going to be a over sine 65 degrees. So a, I don't know what that is, so I can just keep it as lowercase a. And sine 65, I'm changing the capital A for 65 degrees here. Then that's equal to b over sine B. So that's going to be 10 for the lowercase b, 10 centimeters, all over sine of angle B, which is sine 63 degrees. And then that's equal to x, goes in place of the lowercase c, over sine C, so angle C, capital C. Now I can figure out what this angle is, because I know that the three angles in a triangle add up to 180 degrees. So 180 minus 65 minus 63 is 52 degrees. So I can replace that capital C with 52 degrees. So we get x over sine 52 degrees. So I'm going to cross off the first one because it has the lowercase a, so we don't know what that is, we can't use it. But we have 10 over sine 63 is equal to x over sine 52, so we can use both of these. We always use the one with the x in it, or the side that we're looking for, or the angle that we're looking for. And then we use the ones that have the most information, so all the rest of them have numbers. If you don't have enough information in two of the ratios or two of the fractions, then you want to have a look at using the cosine rule. So we can use these two. We're going to let them equal. We're going to cross multiply. So we're going to have x times sine 63 is equal to 10 times sine 52. So x times sine 63 is equal to 10 times sine 52. Make sure the x comes first and the 10 comes first. The sine should always come second. So we have x times sine 63 equals 10 times sine 52. We want to solve for x, get the x on its own. So we're going to divide by what's stuck onto the x, which is sine 63. So dividing both sides by sine 63. Well, sine 63 divided by sine 63 is 1. Anything divided by itself is 1. So you get 1x, or just x. And then stick into your calculator, making sure you're in degree mode. 10 sine 52 all over sine 63 is 8.8440, and rounding to 2 decimal places. The second decimal place is the rounding digit, so this 4 is the telling digit. The 4 tells this 4 to rest. So 5 or more, let it soar. 4 or less, let it rest. So you get approximately equal to 8.84 centimeters, and that's for 10 marks. B. Find the distance y in the diagram below, not to scale. Give your answer correct to 2 decimal places. So we have a triangle and we want to find side y. And it might look like a right angle, because it does actually quite look like a right angle here. But there's nothing to indicate that it is a right angle, so we cannot take it to be a right angle triangle. So we can't use Pythagoras' theorem and we can't use SOHCAHTOA. So we're not looking for the area, so we're not going to use the area formula either. So our two options are the sine rule or the cosine rule. If you try the sine rule, it won't work. So we're going to go for the cosine rule. Well, you always use the cosine rule when you have two sides and an included angle. So the cosine rule is on page 16 of your formula book. And it is a squared equals b squared plus c squared minus 2bc cos a. So we're going to label our triangle. The 53.8 degrees has to be capital A because there's a capital A in the formula. So if you look closely at your formula, you've lowercase a, lowercase b, lowercase c, lowercase b, lowercase c, and capital A. The capital A represents angle A. So we've only got one angle here, 53.8 degrees. So that has to be capital A. So the opposite side will be lowercase a. Then the B and the C, it doesn't matter which way you label them, so long as the capital A is in the right place. So I've decided to let 10.2 centimeters be B and 8.5 centimeters be C. So I sub into my formula. A squared, I replace with y, so we've got y squared is equal to B squared, that's going to be 10.2 squared, plus C squared, so that will be 8.5 squared, minus 2 times B, so minus 2 times 10.2, times C, so that's times 8.5, and then we've got cos A, which would be cos 53.8 degrees. Stick it into your calculator, make sure you're in degree mode. Y squared equals 73.8789. We get the square root of 73.8789. We get 8.5953 and rounding to 2 decimal places. So the 9 is the rounding digit, the second decimal place. The 5 is the telling digit. The 5 tells the 9 what to do. 5 or more, let it soar. 4 or less, let it rest. So the 9 is rounding up. So we get y is approximately equal to 8.60 centimeters. Don't forget your centimeters, and that's for 15 marks.